Okay, so last class we talked about renaming fractions. So we're going to continue with that today, talking about operations with fractions. So we're going to take a peek at addition. If you recall, when we add things like 3 inches plus 4 inches, we have to have the same name. These are both inches. And then when we add, we combine the counts. 3 plus 4 is 7. And we keep that same name of inches. Same thing happens with fractions. In fractions, however, the name is the denominator. This is 1 of something, it's fourths, plus 2 fifths. When we add, we must have the same name. So the first thing we have to figure out how to do with our fractions is to give them the same name. So we're going to set them up like this. For fourths and fifths, what's going to be the same name? What's going to be the common denominator? 20. Perfect. One thing you can almost always do that'll work is just multiply the two of them together. 4 times 5 is 20. Now we need to figure out what do you multiply 4 by to turn it into a 20? 5. So you have to move the 1 times 5 to get 5. What do you multiply a 5 by to get 20? 4. So 2 times 4 is 8. 5 plus 8 is 13. And is that 40th? No, when we add, we keep the same name. So it stays 20.
Why would you put 40?
I was just saying if you guys were awake. So no, we're not going to waste a lot of time just adding simple fractions. We're going to go right into mixed numbers. So let's have like 4 and 1/3 plus 7 and 5/8. What are we going to have for a common denominator here? 24. Very good. Now I rewrite the whole numbers just so I don't lose them. So what do I multiply the 3 by to make 24? 8. 1 times 8 is 8. What do I multiply the 8 by to make 24? 3. 5 times 3 is 15. So now I'm going to add 8 24ths. Now you'll notice I lined up the fractions here just like they're the last digit of the number, because that's really all they are, is just the last digit of the number at the very end. So I have 8 24ths and 15 24ths make 23 24ths. 4 and 7 make 11. Your what hurts? That's what I thought. So anyway, let's try. Sure. So we have 7 and 3/4 plus 4 and 5/6. We need a common denominator. Now we could just multiply the two of them and get 24, but there's a smaller one we can use here. 12. Very good. What's this going to be? 9. Very good. 4 times 3 makes 12. 3 times 3 is 9. What's this one going to be? 10. Good. Now we go to add. 9 and 10 makes 19 12ths. What's wrong with that? It's the improper fraction. So we're going to break it into mixed number. It will be 1 and 7 12ths. So we're going to keep the 7 12ths and carry the 1. 1 and 7 makes 8 plus 4 is 12. You made 24ths? Well, then it would be 14 24ths, and you have to reduce it to 7 12ths anyway.
Are you kidding me?
Let's say you wanted to use 24. This would be times 6, so this would be 18. This would be times 4, so this would be 20. That would be 38 24ths, which is 1 and 14 24ths, which reduces to 7 12ths. Carry the 1.
Doesn't make a difference at all.
That's like 1 plus 1 is 0.
Yeah. Let's look at subtraction.
Oh, my goodness.
Let's look at 8 and 2/3 minus 5 and 2/5. So anyway, common denominator will be 15. So 3 times 5, this is going to be 10. This is going to be 5 times 3, so 2 times 3 is 6. Now we subtract. 10 minus 6 is 4/15. 8 minus 5 is 3. Now, it's not always that simple. We can run into things like this. Bless you. 9 and 1/4 minus 2 and 7/8. First of all, what's our common denominator going to be? How about 8? 16 would work, but 8 works better. So this is going to stay 7/8. This is going to become 2/8. Now we go to subtract here. 2 minus 7 can't be done, can it? So what do we have to do? 2/8 minus 7/8 can't be done. So we're going to have to borrow from the 9 to make this 8. What's this become? What we borrowed was one whole object. And how many pieces are in one whole object? The denominator tells us that. It tells us there's 8 pieces in one whole object. So we got to add 8 to the 2. It's 10/8. When you borrow with fractions, you add the denominator to the numerator to get the new numerator. So now it's 10 minus 7 is 3/8. 8 minus 2 is 6/8. Let's do another example of borrowing with our fractions, just so we can get good at it. Let's do 7 and 3/4 minus 5 and 4/5. Common denominator. 20. This will be 15, and this will be 16. 4 times 5 is 20, so or 5 times 4 is 20, 4 times 4 is 16. Yeah, turn the 5 into a 20.
Multiply 5 by 4 to get 20.
4 times
So you
4.
gotta multiply the same as top.
So now we go to subtract. 15 minus 16 can't be done, so this is 6, and this is... Why did I add 20 to it? The denominator is 20. So this is 35/20. Minus 16 is 19/20. 6 minus 1 is, or 6 minus 5 is 1. That's stupid. We'll call up the math gods and tell them fractions are stupid. So the next thing we want to look at is multiplying fractions. So let's say we have something like 3/4 times 2/5. When we multiply, we don't need the same name. So we do not need to get a common denominator here. When we multiply, we combine counts. In this case, that'd be 3 times 2 is 6. Then we also combine the names. So 4 times 5 is 20. Now, of course, here we would reduce this by dividing both of those by 2 to get 3/10. Now, some of you might be looking at this wondering, why didn't you cross cancel? Others, like Jason, might be wondering, what's cross canceling? Well, when you look at this, this is going to end up being 3 times 2 on top and 4 times 5 on bottom. So you can reduce the 4 and the 2 by dividing them by 2 before we multiply. So now it's 3 times 1 is 3, 2 times 5 is 10. So you get the reduced answer before you reduce everything before you multiply. Now in a problem like this, it's about the same amount of work to reduce before or after. But we can run into things like this, like 24 25ths times 35/36. I could multiply that out, and it's going to get something like 840 over 900 and reduce it. Or I could cross cancel. 25 and 35 can both be divided by 5 to give me 7 and 5. 24 and 36 can be divided by 6, but there's something larger. 12. Give me 2 and 3. So now I have 2 times 7 is 14. 5 times 3 is 15. It's 14/15. Much simpler to cross cancel or reduce before we multiply. So now we're not going to waste a lot of time on simple fractions. We're going to go up to mixed numbers. If I am multiplying mixed numbers, like, oh, let's do 7 and 1/3 times 4 and 2/5. Anybody know how to multiply mixed numbers? Well, that's how we get around it. You can actually multiply mixed numbers, but it's an extremely difficult process. If you went to a university and found 10 math majors, I'd actually be willing to bet that none of them could correctly multiply mixed numbers.
32.
So we avoid it by turning them into improper fractions. This is going to be how many thirds? 7 times 3 is 21, plus 1 is 22 thirds. This is going to be 4 times 5 is 20, plus 2 is 22 fifths. Now, if we could cross cancel here, we would, but there's nothing to cross cancel. 22 times 22 is 484 over 15. So now we have to reduce that back into an improper fraction, or not from an improper fraction back into a mixed number. Remember, that is long division. So 15 goes into 48 3 times. That's 45 with 3 left over. Bring down the 4. Goes in there twice with 4 left over. So 32 and 4/15. Anybody want to see that done without changing it? See how you actually do the mixed numbers? Sure. Don't write this down. I'll never ask you to do this, but let's just do this for fun. When you multiply, not only do you have to multiply the 2/5 times the 1/3. 2/5 times 1/3 is going to be 2/15. But you also have to multiply the 2/5 times the 7. So 2/5, how do you multiply a fraction times the whole number? You get 7 over 1. So it's 14/5, or 2 4/5. Then you have to do the 4 times 3, so 4 over 1, or 4 times 1/3, I should say, which is 4/3, or 1 1/3. And then you got to do the 4 times 7, which is just 28. So now we have to combine. We have to have common denominators. It looks like that's going to be 15. So this will be 12/15. This will be 5/15. Of course, the 28 doesn't change. 2 and 12 is 14, 19/15, which is 1 4/15. So we keep the 4/15, we carry the 1, and that is 32 and 4/15. We get the same answer. This is a lot less work. I'll stick with the improper fractions. Let's do one more with improper fractions, and then we'll look at division. Let's do 7 3/8 times 4 1/3. Tell me what to do. 7 times 8 is 56, plus 3 is 59. 4 times 3, 12 plus 1 is 13. Can we cross cancel anything? Unfortunately, we cannot. So this ends up being 59 times 13 is, or 700 and something. 767, correct? 8 times 3 is 24. Now we got to divide out the 24. 24 goes into 76 3 times, would be 72. That's 4, bring down the 7 is once. So 31 and 23/24. Let's do division. We said division follows the same rules as multiplication. When we multiply, we just multiply straight across. So could we divide straight across? Could we do 12 divided by 4 is 3, 25 divided by 5 is 5. Does that work?
Yeah.
Is that the right answer?
Yeah.
Actually, it is. Does it work every time?
No.
It could work every time. So why don't we do it that way? Well, because we run into problems like this. Well, the math gods do hate you. You have that part right. But I'll get over it. So anyway, you can't do 3 divided by 2 would come up to 1.5. It doesn't divide out evenly. What have you been taught to do? Oh, you've been taught to do the zigzag crap? Yeah. What you do is, instead of dividing by 2/3, you multiply by the reciprocal. 3 over 2. Remember that? Sound familiar? Some of you are taught something called the zigzag method, where you do this. 3 times 3 is 9. 4 times 2 is 8. Yeah, it's bullcrap. Okay. Instead of dividing, you multiply by the reciprocal. So instead of dividing by 2/3, you multiply by 3/2. So now you have 3 times 3 is, you can't cross cancel because you're dividing, not multiplying. Once you've changed it to multiplication, then you can cross cancel, but right now. Yeah, 3 times 3 is 9. 4 times 2 is 8. So 9/8 or 1 1/8. This process, believe it or not, comes from what we just did up here. Once upon a time, the way this would have been done, 3/4 divided by 2/3. They would have taken the 2/3 and said, okay, 3 times 2 is 6. I'm going to rename the 3/4 by multiplying by 6. 3 times 6 is 18. 4 times 6 is 24. 18 divided by 2 is 9. 24 divided by 3 is 8. 9/8 or 1 1/8. So you can divide straight across. You just have to rename the first fraction to make it work. How on earth did we get from this to multiplying by the reciprocal? Well, at some point, somebody was doing this and they realized we're taking 3/4 times 6/6 divided by 3/2. And what they realized is if you took this part here and you divided it first, what you get, 6 divided by 3 is 2, 6 divided by 2 is 3. What you get is just this fraction flipped over. So they define that to be a reciprocal, and then we define division to be multiplying by that reciprocal instead of dividing. Again, you don't need to know where it came from. It's just kind of interesting to know sometimes. We're going to go ahead and do a couple examples of mixed numbers here quick. Let's do 3 1/8 divided by 1 1/2. Now, since we're going to do a reciprocal and multiply, it makes sense that we start out just like we would with multiplication, turning this into improper fractions. So this will be how many eighths? 25, and this will be 3. Now, it's still division, so we can't cross cancel yet. Are we going to flip this over? No. The first one always stays. It's the one we're dividing by that gets flipped. So 3/2 becomes 2/3, and now it's multiplied. Now we could cross cancel. 8 and 2 can both be divided by 2 to give me 1 and 4. So 25 times 1 is 25. 4 times 3 is 12. Will be just a minute.
Okay.
So 25 twelfths, or 2 and 1 12th. So let's do one more example, and I'll give you your homework. Let's do 5 1/2 divided by 3 1/3. Tell me what to do. So this is 11/2. This is still divided by 10/3. So it is 33/20, or 1 13/20. You got her? Now there is a button on your calculator, by the way, if you have the fraction calculator. That's what Jason is using over there to try to make himself look smart for the day. It's the ABC key that you enter fractions. If you want me to help you figure out how to use that, let me know and I will. Otherwise, in your book,
I don't know how to use it.
it is on page 41 through 45. Problems 1 through 89, the odds. And also on page 49 through 52, problems 1 through 87, the odds. Again, I don't expect you to do all of them. Do some of the easy ones, skip ahead to the more difficult ones.
This is his. But mine, remember
Yep.
that one I don't get taken off on, so.
Yep. So that puts you at 94. Yeah, because you got your 4 back plus half of the.
Oh, alright, sweet.
So I got 94 minutes.